Okay, so more stuff with parabolas. Quick review of yesterday. I'm gonna squeeze it up here in the header, right? So jot this down. That says review, I think, right? So the most basic quadratic function is just y equals x squared, right? That was like the first problem we did yesterday. And when we graphed it, that looked like this, right? And where did we find the vertex of this function? Yeah, turning point because that's where the graph turns from decreasing it, right? But I'd say most of the time mathematically you're going to call the vertex, right? But I don't think they use the word turning point on the readings. But either way, it's not wrong, it's just not common. The vertex is more. So where is the vertex found with this? Y equals x squared, everybody. At 0, 0, right? And then do you remember, I think the second one we did was y equals x squared plus 2, right? What did that do to the vertex? So like if you're thinking of your table of values for x squared, you're taking all of them and just adding 2 to it, right? So it just lifts the whole thing up. So 1, 2. So there, it moved it up 2 units, right? We didn't do one like this, I don't think, but I think now you can figure it out. What if I had y equals x squared minus 3? What would that do to the parabola? Just shift it down 3, and the vertex would now be like down here, right? Okay? So if we add something or subtract something to the end of x squared, it moves it up or down, whether it's positive or negative, right? And by the way, you might hear, like this basic one, x squared, and maybe some of the Regents questions, they'll call this the parent function, right? And then these two are just tweaking the parent function a little bit. So if you see the term parent function, that's kind of what that means, right? Okay? So this would be the parent function of these two, and we're comparing them, yeah? And by the way, all of these that we did here are concave what? Up. These are all concave up. You agree? Concave up. Okay. So let's look at a slightly different version of this parent function. What is the function in exercise 1 there, kids? Oh, real quick, by the way. All these vertices, the y values of them, were they max or mins? Mins, right? Okay. Concave up, the vertex would be a min, right? Okay. So now we have not y equals x squared, but y equals what, kids? What do you think that's going to do to the parabola? Just take a guess. Oh, you got some decent instinct. You might just flip the thing upside down. Reflection? Remember doing reflections and translations and rotations? You think of the table of values, right? For x squared. So when you get out your x squared, then you just make it negative, right? Okay. So let's do that table. So an x of negative 3, right? It's going to be negative 3 squared, right? Which is what? Yeah, because negative 3 squared is positive 9, then the negative of that would be negative. If you're confused, because I know I said everything that you square ends up positive, right? Is anybody confused about, or this ends up negative, this is negative. Negative 9. Is anybody confused about the fact that I told you everything you square becomes positive, but we have a negative here?
Because it's on the outside.
Yeah, it's because we do square it and get a positive, and then we take the negative of that. So what are the coordinates of this point? Negative 3, comma, negative 9. So let's just keep going. So negative 2 squared is what? Negative 4. And from now on, I don't want Carly to answer anything. Take that as the highest compliment, Carly, when I do that, okay? You know why they say it, right? Because obviously, when I want to hear from everybody else. So what are the coordinates? Not Carly. -2, -4. There we go. Keep going. -1 squared is what, everybody? Coordinates? All right. How about -0 squared? What's that? 0. Coordinates. -1 squared is -1. So 1, -1. Are you starting to see a little symmetry here now? Or, yep, not -2. Negative what? 4, right? 2, -4, and -3 squared is -9. So, okay? Hey, looking at your table, by the way, do you see the vertex? Where? What point? It's 0, 0, right? And remember, remember yesterday when I asked you to make a table of values for one, I said find that vertex first and put it in the middle of your table and then take a few points before and then after. Anyway. All right, so go ahead and plot these points. Draw a nice smooth curve. That's not a V through them. Not a V, all right? So, -3, 1, 2, 3, 4, 5, 7, 8, 9, -2, 2, 3, 4, 1, 0, there, there, and there. Okay. But as a parabola, it looks about like that. So what? Yeah. -3, -9. Right. Okay, so here's our vertex. That's at 0, 0, right? Now, does that represent a max or a min? This is a maximum now. Okay. All right. So down right below it, they want the range of it. The range is all what values? X or Y, kids? And someone asks you for the range of a function. That's all the X values or Y values? It's all the Y values. What is the range of this function? So y's are what? We'll write y. Wait, -9, no. We got arrows, right? Goes to negative infinity, right? So we'll say y is what? Less than or equal to 0, right? So 0 out of that. It's, by the way, we're writing our range like this. Remember the Regents question? They'll probably use the soft and hard bracket thingies, right? So just be ready for that. It's at the top, it's the highest value, right? That everything on that graph is the outputs of the y's, right? And there's not one higher. But if it's concave up, then that vertex is going to be a what? Minimum, right? It's going to be a low, right? Okay, let's move down here. So, oh, and by the way, what is it you think made this thing concave down? The negative in front of what? The x squared, right? In other words, the a. But and we didn't do this. They said write it in this form. This would be y. What's in front of this x squared, actually, kids? Not 1. -1 times x squared, right? Now it's like in the ax squared form. So the a is -1, right? And it was concave what? Down. Right. Moving along. So what they want us to do here is put each of these in your calculator and just make a rough sketch of them. But what I do insist on is that, yeah, rough sketch, but I want to make sure you identify the y-intercept when you do it and make sure it goes through the y-intercept correctly on here. When you put it in your calculator. Now, before you start punching in, set your calculators down for a second, everybody. Remember, the y-intercept is where it crosses the y-axis, right? And what is the value of x at any y-intercept? 0, right? Okay? And so if I'm looking at this equation, can you tell me what the y-intercept will be looking at this equation here? Why would it be -4, Clarence? You're right. Huh? Well, it's not really y. Indirectly it is y. But what did we just say the value of x is at the y-intercept? 0. Now in your head, put a 0 into that x and that x. What's left for that equation? -4. That's it. When you get 0 plus 0 minus 4, you look confused. What's 6 times 0? What's 0 squared? 0. And what's 3 times 0? So 0 plus 0 minus 4. That's all that's left. So x is 0. You must have a y-intercept at -4. Like right about there, right? Okay. Now put in your calculator, and your rough sketch should definitely go through y of -4. X minus 4. 3x squared. 6x minus 4. Everybody graph look like after the first one? Okay. So it's about like this, kind of. This is really rough, but okay. So our y-intercept was what? Y equals -4, right? Huh? And is this, what's the concavity of this? It's concave what? Okay. All right, move on to the next one. What is the y-intercept in the second one? 1. Because if you put a 0 in for x, everything goes away that has an x in it, right? You're just left with 1. So it's going to be right there, isn't it? Huh? Oh, look at your equation. Somehow you didn't come down out of the exponent when you put the rest of it in. Yeah. Right? Yeah, right? The only thing is, so the 2 is the only thing that should be in the exponent. So we go right there. Yep. So that's a 1. Everybody's graph's about like this one. What's the y-intercept? 1, and it's concave how? Concave down. Okay. And then the last one, look at the equation. What's the y-intercept? -4. Again, so probably about there, right? And use your calculator and get a rough sketch that goes through that -4. So the y-intercept is y equals -4, and that's concave how? Okay. Now my question is, without graphing these, looking at the equation, it seems like you can all tell me what the y-intercept is, right? Just looking at the equation. Can you look at the equation and tell me if it's going to be concave up or down before you graph it? How? So take a look at the last one. What tells you that? Look at the equation. What about this equation tells you it's going to be concave down? Negative what? It's the number in front of the x squared, right? The negative 4 on the end just moves it down from whatever it's going to be, right? This is the thing that causes it to reflect down. The negative a, right? So what about the second equation tells you it's concave down? The negative 1 in front of the x squared, the a, right? Okay. And what about this equation tells you it's concave up? The positive 3 for the a, for the x squared. There we go. Okay? So now listen, so we're looking at how these things change, right? So yesterday, just like tacking on something at the end of it plus something minus something does what to the graph? Here, what does it do to the graph? When you just tack, like add or subtract something at the end.
Oh, it's just how.
What? Makes it go up or down by somehow, right? Huh? No, it moves the vertex up and the whole graph up and down.
Oh, yeah.
Right. And if we multiply, have a negative in front of the x squared, what does that do to the graph? Yeah, it reflects it, makes it concave down. Okay? So let's look at doing some more stuff to it. So now we have a few more. And what I want you to do is on your notes, you're going to sketch these all separately. Listen to me. Stop. Everybody stop. All 6 of these, I want you to put on the same graphing window. Okay? So you can kind of compare them all. So we're going to have 2x squared, 3x squared, 4x squared, all in the same graphing window. Don't delete one when you go put the other one in, and then we'll see what's going on here. And by the way, all of these, and the first 3, are going to be concave which way? Up. Good. No, the F of X or your Y in there, yep. So your first 3, does it look kind of like what I have up there? Mm-hmm. What did you notice as you went from 2x squared to 3x squared? To 4x squared. How? Different how?
The bigger number, smaller, but.
I mean narrower?
Yeah.
It's skinnier, doesn't it? Or think about your table of values for x squared. Everybody stop what you're doing real quick. For x, when you have a table of values for x squared, and now you take all those output values and say multiply them all by 2. It makes those numbers do what? Get bigger, multiply by 2, right? Right, so it'll climb faster, right? So doesn't it really, as we increase that A, doesn't it get taller and narrower? Right, so y equals 2x squared, like this maybe. And then 3x squared is a little skinnier, right? And then 4x squared is really skinny. Okay? But you have them all in the same street. Now, when you do the next street, keep those 3 in there as well, okay? The next street, what can you tell me about their concavity? Down, right? So they won't even get in the way of the other 3 you have, right? Okay, so put all those in. Negative 2x squared. 3x squared. So they look a lot like the first 3, but just flipped down, right? Mm-hmm. Should be a simple fix. All All right, so these are going to be just reflections of the ones above them, aren't they? But when we put them all on the same screen, it was kind of clear to see what, you know, what was happening, yeah? Okay. So with a larger A value, they get narrower and taller, right? But what do you think would happen with like an A value of like 1/2 then? Yes. What do you think that would do? Think of the table of values for x squared and then multiplying them all by 1/2. Mm-hmm. So multiplying by 3 and 4 and 5 makes it climb a lot faster and skinnier, right? What would multiplying it by 1/2 do? It'd get wider, wouldn't it? Right? Because you take all the values for x squared and divide them by 2, so it's going to climb a lot more slowly. Okay? But we'll get to those later. All right. So we know adding stuff at the end or subtracting moves it up or down. Multiplying the x squared by a negative reflects it down. And the number in front of the x squared, the a, as that gets bigger, the graph gets what? Skinnier, right? Narrower, taller, really, right? It's hard to say taller, right? Because it's already infinitely tall. So it almost doesn't make sense to say that. So we'll just stick with narrower, right? All right, so let's kind of summarize here. So we had a quadratic. It's in this form. Y equals ax squared plus bxc plus c. Fill in the blanks. The parabola will be concave up like this if what? What about a? If a is what? All right. Anybody know a different way to write a positive? Right, yeah, whenever you see something greater than 0, you can think positive, right? It can't be equal, right? Because zero is not positive or negative, right? Right, so this is another way to say positive. And it'll have a minimum y value and be concave down when a is what? Less than 0, also known as what? Negative, right? Okay. Now, before we get to Regents' questions, I want to give you a thing. Carl, you might not want to miss this. Unless it's a super emergency. They don't give it to you here. We're going to need it at some point, right? It says note. Let's go to our notes page real quick. To find the axis of symmetry algebraically, like if you're given the equation in standard form, okay, there's a way to find the equation. Now, you remember the axis of symmetry goes down and cuts through the x-axis, right? It's that center, the symmetry line for the parabola. So its equation is always x equals some number, right? It cuts the x-axis, right? Well, here's how you can actually find it. So axis of symmetry. Right, to get the equation. So let's say I have y equals ax squared plus bx plus c, right? And let's say that's a graph. I'm just going to random parabola graph here, right? Let's say it just kind of looks like that, right? There's my vertex. And there's my axis of symmetry. Seems a little off, but you get the idea, right? And the equation for that axis of symmetry is x equals something, right? Because it cuts what axis? X-axis. And this vertex is x comma y, right? And aren't they the same x? Okay. All right, so when you have your equation in this form, you know how to find what a and b and c are, the numbers, right? All right. Well, the axis of symmetry is the equation x equals negative b over 2a. That simple. You take a, b, and c and put them in there, you get a number. And that's the equation for your axis of symmetry. Okay? Give you an example. So remember this, x equals negative b over 2a. Let's take y equals 2x squared minus 8x plus 3. Okay? And I want to find the axis of symmetry. Well, it's x equals negative b over 2a, right? So x equals, tell me what to put in there. What's the value of b? Negative 8. So what should go on top? I thought it was supposed to be negative b.
Negative and then parentheses.
Right? Negative, it's negative b.
So you put the negative 8 in front of
B is negative 8, so it's negative b, so negative 8, right? Don't make that mistake. You guys get me, right? You understand that? Just because it's already negative doesn't mean you ditch the negative from the formula, right? All over what? What's A? 2. 2 times 2, right? So what's negative 8? So it's 8 over 4, so the equation is x equals what? 2. So that would be the equation, x equals 2, for that axis of symmetry. Okay? And by the way, for our vertex, what's the x value for it? It's 2. How would we find the y value? How do we ever find a y value if we know what x is? Huh? The y value is 3? Why would we? It's the y-intercept. Guys, whenever we have an equation and we have an x, how do we find the y that goes with it? Plug it in. Yeah. Right? So once you have the axis of symmetry, that's the line x equals something, but remember, that's also your x for the vertex, right? So once we have that, we can find the coordinates of the vertex, right? That's going to be y equals 2 times 2 squared minus 8 times 2 plus 3. So I want you guys to go ahead and calculate that now. See what you get. What'd you get? We'll see. You got negative 9. What'd you get? 4. We're over now. Kale, what'd you get? 10. Let me guess. Okay. Stop what you're doing. Everybody. How many of you started by doing 2 times 2?
I did.
Sure? Because that's wrong, right? You all know that.
Just did it.
You have to do what first? Square it. Okay, so this is 2 times 4 minus 16 plus 3. 8 minus 16 is what? Yeah, you said negative 9.
I know, because I did the math
Oh,
wrong.
8 minus 16 is negative 8, plus 3 is negative 5. Right? So the coordinates of our vertex are what, comma, what? 2, comma, negative, yeah. 2, comma, negative 5. All right, you follow me? Axis of symmetry is x equals negative b over 2a. If b is negative, you have the negative of the negative. Everybody get that, right? Okay? It's just not like, they don't make it negative b, to say, well, if it happens not to be negative, make it negative. But if it already is negative, you're fine. No, it's negative of the entire b. Hope we understand it, okay? All right. Let's set a couple of these reading questions then. All right, read that first one. I want to do this without graphing. You can always throw it in your calculator and figure out how to do it. So they want us to find the what of this function? What is the range of a function? All the y values. So wouldn't it be nice to know, first of all, is this thing going to be concave up or concave down? Up. Wouldn't it be nice to know the coordinates of the vertex? Right? Because then you could say all your y's are greater than or equal to whatever that value is. Okay, well, on the page before, just a moment ago, did I show you how to find the coordinates of the vertex? In the page before, we have to find what first? Which is the x equals, this is the axis of symmetry equation, but it's also the x and the vertex, right? Okay. So we do that x equals what? Negative b over 2a thing? Okay. So do that here. And you can actually leave your answer as a decimal here. So it'll be x equals what, kids? You said two negatives? Okay, negative 2 over 2. What's the a? 2. There you go. So it's 2 over, which is really what? Huh? A half. So let's make it 0.5. Well, that's x, but right, range is the y, so we need the y value for the vertex, right? How are we going to find that? Plug it in. Yeah. Plug that in. So h of 0.5 is going to be 2 times 0.5 squared minus 2 times 0.5 minus 4. 0.5 times 0.5 is 0.25. But you guys could just put this whole thing in your calculator as one thing. Couldn't you? Well, put the whole thing in your calculator. What do you got? What's the number? Well, let's take it.
4.
No. Just punch this in your calculator.
Oh,
Well, what else would you put in there? Why would you do that? We need that.
How you go back? Just go up.
Yeah, you can do that. Hit enter and bring it down. It's probably quicker just to retype it. What is it? 0.5, yeah, squared minus, what was it, minus 2 times 0.5? And what was it then, plus 4? Plus 4? Minus 4? Negative 4.5. Why did that take you so long? Jeez. Okay, so negative 4.5. So our range will be y is what? That's a min, right? Greater than or equal to negative 4.5. But they have the different notation. Which choice? Well, why not 3? Yeah, this is not including it, right? We have an equal, right? So it's choice 4. Okay. So read over number 2. It's all fed in the piecewise function.
Aw.
Well, you know how to put them in your calculator, don't you?
I kind of know.
Yeah. Well, anyway, I think you might want to actually open a document to put that in to get the table for that, I think. I'll try it. I'm going to do it with a new document to be safe. So do you remember where to find it home? 1 and 2 for add graphs. Remember how to find piecewise in your thing there? Everybody remember? See the 9 button and this button directly to the right of it? Push that. You see this one here with the commas? Right? Let's see. It's going to be 5x. 5x. And do you remember where to find the less than and greater than things? Or x. Who remembers where to find the inequality signs? Control equal, right? And we want less than or equal to 3. And we go down here. We're going to have x squared plus 4. And we want for x greater than 3. Wait, I almost forgot. Greater than 3. We got to adjust the window here somehow for this. Let's try it a different way without the calculator. Okay. So where's the point that's going to have either open or closed circle? What value of x? So at 3, right? So the 3 for which one of these will have the closed circle, the top or bottom? Okay. And you see the choices here. So why don't we figure out what a value of 3 gives us for the first one, right? So what is actually g of 3? Because it goes here. It's going to be 5 times 3, right, which is what? 15. And what are the coordinates of that point? So that would be 3, 15. Okay? Now, let me write something this way. I'm going to find g of 3 again, but I'm not going to write equals because I'm going to see if you can figure out what I'm doing. You see what I did there? And so now why did I put not equals? Because I'm going to put this in the bottom. Yeah, but I'm going to put it in to see where it, right? Because I want to open close where it is, right? So it'll be 3 squared plus 4, right? Which is 9 plus 4, which is 13. What are the coordinates here? Okay. Now, between the 315 and the 313, which one gets the closed circle? So this will be the closed, and this one will get what kind of circle? Open, because it's really not included there, right? So that's, yeah. Right, so do you understand now how to do one like that? Last class, I forgot what I had done there. I tried to pull up the calculator to see where it was, but it just got hairy and gnarly. Yeah, so choice 4. Okay? So yeah, when they ask one like that, just figure out, all right, 3 is the part where, they split up 2 graphs, put it into both and see which one's open. All right, let's look at number 3, little physics. This is a real common problem in physics, projectile motion, falling bodies. This kind of thing actually models, you know, if you threw your buddy off the roof, this would describe exactly how long it would take for him to hit the ground.
Wouldn't that depend on the weight?
Right? No, it doesn't. Oh, yeah, no, the weight has no effect with gravity. Let's say I take this marker and I go into the weight room and I get a 45-pound plate and drop them at the same time. Which one's going to hit the ground first?
They both.
They hit the ground at the exact same time. Okay,
Yeah.
what do you think? That's a good question.
Because it was
Why does it
space.
go through it slowly?
Because it has more, holes.
We're talking about mass too.
Yeah, we're talking right now just about mass. So mass has no effect. We're off the topic here, but this is worth talking because mass has no effect on how fast something will fall to the ground, how long it will take to drop to the ground. So a feather and a 100-pound weight should drop and hit the ground at the exact same time. But somebody has said the feather's not going to. How come? What if we were on the moon? What's different between here and the moon? Well, gravity, yeah, but the air. The feather catches the air or atmosphere, right? So if we took the air out of it, what do you think then? Okay, so you remember, you don't remember, I do, when NASA put men on the moon? Okay, one of the experiments they did, I think it was Buzz Aldrin, he brought with him on the spacecraft a feather and a hammer to test this very thing out. So it was funny, you guys met, so who said feather, by the way? Yeah, I immediately remembered that. This guy was on the moon, he had a feather and a hammer, and he had the videotape rolling, just wanted to prove that Isaac Newton was correct, and he held them both, there's video of it, he dropped the feather and the hammer, and they both hit the surface of the moon at the same time. Because there's no air. The only thing that slows a feather down is the air resistance. And it catches the
I
air.
realize that smart people can plan out murders better than.
Well, yeah, murders and all kinds of other things. Yes,
You
that's
think some of
true.
the time it takes to push someone off.
Right. That's why it's important to get a good education, kids.
Isaac Newton was
You
really
have
smart.
forensics. That
Was he?
teaches people
Yeah, that's
how
why
to
he
do
didn't get
murder.
like.
Yeah.
He should have-
Oh, no.
Everybody was mean back then.
All this place
It was the 1650s. People were mean. I don't know.
is like-
Okay, so anyway, let's get back to this falling body motion. Read the problem. Yeah. What's this about? Well, not really. Yeah. So he's on top of good. He can just reach his hand out and drop the ball. What did he do? He threw it up, right? Okay? Or he might have just thrown it straight out. They didn't really say. So they want us to graph this, right? So what do we need? Well, instead of X, we're using what? Let's think about what this models, okay? What does this H represent? The height of the ball. And the T represents what? Time in seconds, and the height is in feet. So this equation will tell you exactly the height of the ball above the ground after any given number of seconds. Okay? That's math does that for you, right? So anyway, we need a table of values, right? So we should make a table of values. This is a real life situation from a T or X of what? Starting at X or T time of 0, and then a table that goes out to what? 5 seconds, right? Okay, so let's put this thing in our calculator. We don't have to worry about the window right now. Let's just get a table of values, okay? So just use your calc and the table function. All right? And so we'll do, well, right now we just want the table. You might not even see the graph, but you can still get the table. So T, and then H of T for really what it should say there. And it'd be 0, 1, 2, 3, 4, 5 seconds. But of course, instead of T, you're going to use what? That's right. So don't worry, you can't see the full graph right now. We'll fix that in a bit. So let's now get a table in here. Everybody okay? They got a table? You able to get your table? Why aren't you getting the table? Don't copy my table. No, don't copy my table. Where's your table? Okay. So let's see. Good question here, guys. Are we going to entertain a time of 5 seconds for this problem? What about that time of 5 seconds? What are we going to do about that? It's a real life problem, right? This is the ball's height above the ground. At some point between 4 and 5 seconds, what does the ball do? Hits the ground, 0, right? So we're not going to deal with the negative. So let's go ahead and plot these points. So we got 1, and you can kind of estimate where they go for some of them. 60, 2 is it? 108 is there. Wait, what do they do? Oh, that's not 1. 0, 60. And then 1, 108. And then 2 is 124. 3 is 108. 4 is 60. And then somewhere down here it hits the ground. All right. About right. Notice we don't have the whole parabola here, right? If we were using the full graph, wouldn't it be out here the negative time? Wouldn't this be negative time? And we're not going to deal with that though. Okay. So we understand how to get the graph from a table of values. And now you could adjust, like if you wanted to see this on your calculator, we don't really need to, right? You just change your x to go from 0 to 5 and your y from 0 to 150 like they have there, right? All right, we're assuming it's not going to go 20 feet, right? Yeah. You're only going to be interested when it hits the ground, okay? I would say, like, probably the Army uses an equation for missiles that will do that when they want to hit something and they want to penetrate, and then they'd have to have change your equation. It'd be like a piecewise, right? Because it's going to have different dynamics going through a concrete bunker. It's going to slow it down, so it'll be a different equation at that point, right? So, yes, right. See, smart people. You want to get away with murder, become a mathematician. That too, oh my God. Like if me and Mrs. Doherty ever joined forces, none of you'd be safe. Nobody ever hear from me again. Of course. It's all just absurdity. All right, average rate of change. Please, God, tell me you remember how to do average rate of change.
Yeah.
Yeah. No, just that one. FB minus FA over B minus A. So now we're using H. They want the average rate of change from what to what? From when what? You gotta read from.
And when he released the ball.
From when he released, okay. What was the time when he released the ball? T equals what?
0.
Wouldn't that be T equals 0? To when the ball reached its maximum height. Aha, here's your maximum height, right? It's at that vertex, okay? Maximum height would be T equals 2. So, it would be F of what minus F of what? 2 minus 0 over 2 minus 0. Well, finding F of 2 and F of 0 should be easy. You got your table there, right? Well, it's going to be H, isn't it? I should be consistent. They're not using F, are they? They're using H for height. So H of... All right, you guys all do it. Go to your table. Good girl. It's on your table. You put it. I'm not going to do it. You do it. Son, it's right there. Did you write the table down? Yeah, put those numbers in the down here. Yeah. What's H of 2? What's H of 0? What's stopping you?
Okay.
Spend the rest of the orangutans here a moment, Charlie. Monkeys make you laugh too? You ever see one that like wearing a full suit and carrying a briefcase? You know, drive the car or something. Used to be a TV show on when I was a kid. It was called Lancelot Link, Secret Chimp. The monkey was a spy. He wore a suit, sunglasses, and hat. He drove a convertible. This was not a cartoon. It was an actual monkey. He had a monkey girlfriend. Wore a dress and was just, come on.
Stop talking. Monkey's more successful than us. Please stop.
I would say, yeah. I was never able to get into the CIA. This primate did. Well, what did we get?
64.
You finish it out.
Oh, 32.
32 feet per second?
Yeah.
Right, because you did 124 minus 60 over, well, that's 2, right? Which is 64 over 2, which is 32 feet per second. Okay? So, we'll pause it there. So somebody remind me on Monday we need to finish the other 2 Regents questions. Okay?
We have plenty of topics.